Okay, short assignment for 11.8. All right, so here's another more practical way to use expected value. The table shows claims and their probabilities for an insurance company. Use the table to answer parts A through C. So it has already created a table for you. The first column is the amount of the claim. So somebody buys, let's say this is homeowners insurance. Somebody buys homeowners insurance, and a lot of times a claim on a house, for your insurance would be small. You had some small damage from a storm, or something small happened to your house. And the probability that you would have a claim that's close to $0, that doesn't mean that it's always $0. Notice that at the top it says it's rounded to the nearest 50,000. So this could be anywhere from less than 25,000 down to 0. But the probability that you have a small claim is 0.65. So it's actually a high probability that you will just only have a small claim. The probability that you have a claim close to 50,000 is 0.24. The probability of your claim of 100,000 is 0.07. A claim of 150,000 is 0.02. Notice how much smaller the probabilities are getting. And then the probability of a claim of 200,000 is 0.01, and same for 250,000. So it's like a 1% chance that you're going to need to have a huge claim from this insurance company. All right, so to find the expected value, what do we need to do? Well, before you add, multiply. Okay, so we need to multiply each outcome with its probability, which, if you wish, you can create a third column here for your products. All right, so you're going to multiply and place your answer in the third column. Okay, the first row, what's 0 times 0.65? 0, good. Okay, 50,000 times 0.24. 12,000. 100,000 times 0.07. 7,000. 150,000 times 0.02. 3,000. 200,000 times 0.01. 2,000. And 250,000 times 0.01. 2,500. Okay, any questions on those products? So now what do I do with these numbers? Add them together. Okay, so add up all of these. 26,500. And this is your expected value. Okay, multiply and add. That's your answer. Okay, so 26,500. Fantastic. Okay, now you need to understand what that means. Okay, so if you're ever asked to describe what expected value means, you should always start with the words over the long run or something similar to that. Okay, so over the long run, what would happen? Let's say you're the insurance company, and this is what the expected value is on your clients. Okay, so over the long run, each of your clients is going to cost you $26,500. Now, some clients will cost you nothing. Some clients will never make a claim on their insurance. But then you'll have other clients that cost you a lot, and you have to pay out a whole $250,000. But over the long run, it's going to cost you about $26,500 to make sure that you can take care of all of your clients. Okay? So, if this is the case, how much should the company charge as an average premium so that it breaks even on its claim costs? The same amount as A is correct. Good. Because if this is about how much it's going to cost you per client over the long run, then if you take in that amount from each of your clients, then you'll make sure that you have everything covered. You'll break even. Okay, that's what breaking even means, is that you don't have any, you're not under what you owe, but you also are not making any money on that. So breaking even is $26,500. Well done. Okay, so, and again, this does not mean that they're going to collect $26,500 today from their client. Okay, they're going to break that up over payments from them. But the payments are based on how much they want to make sure they earn over a certain period of time. All right, so how much should the company charge if they want to make a profit of $50 per policy? Very good, $26,550. All you have to do is add what the profit is to what your break-even price would be. Okay, nice work. So breaking even means that you need to bring in as much money as what the expected value cost would be. A profit means you have to bring that much more in above the expected value, and so on. Okay, one thing I want to point out before we move on to another problem. Go ahead and add up all of these numbers in the probability column. So you have 0.65 plus 0.24 plus 0.07 plus 0.02 plus 0.01 plus 0.01. What do you get? 1, okay? So this column adds up to 1. In the previous problem that we had about the roulette, we had, well, no, even before we get to the expected value, just the probability column, we had 1 out of 38 and 37 out of 38. Okay, so the probability of landing on 20 was 1 out of 38, and the probability that you land on some other number was 37 out of 38. So what do you get when you add these two together? You get a 1. Okay, so something to keep in mind in your problems for expected value, that your column for probability should always add up to 1. Because remember that 1 means that absolutely something is going to happen. Well, yes, it's definitely one of these outcomes is going to happen, so they all have to add up to 1. So you're either going to win or you're going to lose. Absolutely, no doubt about it, okay? So all those probabilities have to add up to 1. An architect is considering bidding for the design of a new museum. The cost of drawing plans and submitting a model is $17,000. The probability of being awarded the bid is 0.1, and anticipated profits are $170,000, resulting in a possible gain of this amount minus the $17,000 cost for the plans and the model. What is the expected value in this situation? Okay, so in the last problem, the chart was already made for you, but pretty much most of your problems, the chart is not made. So we're going to go back to that chart that I showed you already. We need a chart of outcome. Okay, so outcomes, gain or loss, and the probability of that happening. Eventually, we'll have a column for products, but we'll get to it when we get there. So this is the main thing that you need to remember here to create your chart. All right, so an architect is bidding for this new museum. What are the possible things that could happen when he bids for the job for the museum? Okay, he could get the job or not get it. Okay, so, and they use the word awarded the bid, so I'm going to just use that same wording. So he's awarded the bid, or he's not awarded the bid. Okay, so if he is awarded the bid, what is his gain or loss? So It's going to be 170,000 minus the 17,000. Okay, so they even told you that right there, possible gain of. All right, so we have 170,000 minus 17,000. What is that equal to? 153,000. Okay, the probability of being awarded the bid is not, well, careful, I'm not quite sure how you said that, but be careful, it's 0.1. All right, so then what is the gain or loss if he's not awarded the bid, he or she? Okay, 17,000, is that a gain or a loss? It's a loss, so we need a minus, right? So minus 17,000, because it's going to cost him that much money just to put together the bid. Okay, so that would include, man hours, any materials that he might use, floor plans that he has to make. Maybe they make a model of what it would look like. Okay, all kinds of costs that might go into doing that. So if he doesn't get this job, he's out that amount of money, he or she. All right, so what's the probability of not being awarded the bid? 0.9 is correct. Good. They did not tell you this in the problem, but the pattern that we just learned was that this column had to add up to 1. Okay, so in order for this column to add up to 1, this must be a 0.9, so that 0.1 and 0.9 add up to 1. Now, you don't have to guess. You could always just do 1 minus the 0.1. And that'll give you the answer. Okay, so 1 minus the 0.1 will give you the 0.9. All right, so we've filled in all the information we need for the chart, and so now we need our column for products. So we are going to multiply our gain or loss with its probability. And so 153,000 times 0.1. Okay, 15,300. Negative 17,000 times 0.9. Minus 15,300. 1530. Did everybody get that? Okay, I'm going to check it because we've got disagreements here. So 17,000 times 0.9 is 15,300. So negative 15,300. Okay, make sure you had the right amount of zeros and make sure it's 0.9 when you're typing it in. All right, so now when we add these two numbers together, what do we get? Okay, so but the value is 0. That's our expected value right there, $0. Okay, so we're going to type in a 0. Well done. And now it wants you to choose the correct statement for what this means. Okay, so you have choice A, B, C, D. We'll do choice 1, 2, 3, and 4, and I'll read them out to you if it's a little small. So choice 1, in the long run, the architect would expect to break even. Choice 2, in the long run, the architect would expect to earn this amount. Choice 3, in the long run, the architect would expect to lose this amount. And choice 4, none of the above. Okay, so 1, 2, 3, or 4. And I see a majority with 1. And the majority is correct. Fantastic. Okay, so if you get an expected value of 0 when you're talking about money that you're either going to earn or lose, then yes, that is breaking even. So this means that if this architect continues to bid on these huge jobs, it's a huge job, okay, a museum. It's got a high risk, okay? There's not a lot of museums being built these days, right? So the probability that he get the job, there are a lot of architects, not a lot of museums, is just 0.1. But at least he would break even on this job. So he would earn what his costs would be. And this is not just on one job. This is if you continue to do job or bid for jobs like this. Because what this means is that, you might not get the bid for this museum, but then later there'll be another big project similar to a museum that you bid on that's got the same, same intent on that job. Maybe you get that one. Then maybe the next couple ones that you bid on, you don't get. So you earn some money, you lose some money, you earn some money, and so on. So over the long run, you're going to get an expected value of 0. This may or may not be a good move on the architect's part. Now, it all depends on what their focus is. So breaking even on this job, he can't live on breaking even. But there are other ways that he can compensate for that. He could also do other types of jobs for his firm and make money on the other types of jobs. This might be a good PR job. Okay, maybe you break even, but your name gets out there and you don't have to pay money on the publicity and advertising that you would need. Okay? So there are certain reasons why you would want to break even, and that's okay. And other types. Now, maybe he's a nonprofit architect. I don't know too many of those, okay? but in a nonprofit, if in a nonprofit job, you are trying to break even. Okay, that's the whole purpose of that nonprofit organization, is that they need to spend the funds that are coming in, and so on. Okay, so let's take a look at one more. Okay, a store specializing in mountain bikes is to open in one of 2 malls. If the first mall is selected, the store anticipates a yearly profit of $75,000 if successful, and a yearly loss of $25,000 otherwise. The probability of success in this particular mall is 1/2. If the second mall is selected, it is estimated that the yearly profit will be $50,000 if successful. Otherwise, the annual loss will be $15,000. The probability of success in the second mall is 3/4. Okay, so you're opening a store. You have 2 different locations to do this in. You have hired a research team to find out this information. They have studied lots of different businesses in these areas, and this is what they've determined based on what they have, that information that they have. Okay, so it says, what is the expected profit for the first mall? So notice that it's shown you, you're going to do an expected profit for the first mall, and then you're going to do an expected profit for the second mall. So we actually have to do 2 charts for this problem. All right, so for the first one, again, we have outcome, gain or loss, probability. Okay, so you go to the first mall, you open a store in the first mall, and what's the possible thing that could happen? Think about the words that they used in the problem. Successful, right, was the word that they used in there. So you could be successful or unsuccessful or not successful, however you put that. Okay, so if you are successful in the first mall, then what is your gain or loss? Okay, 75,000, they told you that right here. So, and is that a gain or a loss? A gain, so it's a positive number. So, profit of $75,000 is successful. Okay, and if you're unsuccessful? Okay, so it's right here, that 25,000, but since it's a loss, you need negative 25,000. Okay, what is the probability that they gave you? 1/2. Probability of what? Success. Okay, so if you're successful, or the probability of being successful is 1/2. So I need to put that in the row for successful. So what would be the probability of being unsuccessful? That's the success of the other mall, the 3/4, but I did hear somebody say it. It was 1/2, right, because remember that this column has to add up to 1. Okay, so there's our first chart. Let's go ahead and multiply. So 75,000 times 1/2. Okay, let me use a different color here. So 37,500. So I didn't make my column. This is my products. Okay, what is negative 25,000 times 1/2? Negative 12,500. Okay, add these two numbers together. So 37,500 and a negative 12,500. Okay, so I heard 15,000. I heard wrong. 25,000. Okay, good. Okay, so 25,000 is our expected value for the first mall. Okay, these were yearly profits and losses. So this means that, the expected profit for this first mall would be 25,000 a year. Okay, so everybody got that? So typing in $25,000. Fantastic. Math Excel is very happy with you today. Okay, what is the expected profit for the second mall? So now I want to give you guys an opportunity for a couple minutes to see if you can do this chart from scratch. Okay, I'll write out the information a little bit bigger in case it's hard to read. But the second mall says that it's an estimated yearly profit will be 50,000. And then loss of 15,000. And the probability of success is 3/4. Okay, let's see how you did. So we've got outcomes, gain-loss, probabilities. Okay, what are the outcomes of this one? Successful, unsuccessful. So nothing's changed here. Okay, and so the gain or loss if you're successful. Okay, positive 50,000. And if unsuccessful, negative 15,000. The probability of success at this mall? 3/4. And so therefore the probability of being unsuccessful? 1/4. Good, because this has to add up to 1. So now multiplying across, okay, so what was the first one? 37.5. And then 15,000 times 1/4? Negative. Okay, negative 37. No, that doesn't make sense. Okay, so I didn't hear right. So, oh, okay, so, okay, so 3,750. Okay, so, but I heard some people got different numbers. Everybody okay? I just want to make sure everybody's on the same page. Okay, so maybe make sure you put in 3 zeros. So, Okay, so yeah. So again, a lot of it is just double checking to make sure you type those numbers in correctly. So now when you add these numbers together, 33,750. Okay, so this time your expected profit is 33,750. Okay, so 33,750. There's still one part remaining here. Well done. Okay, so choice 1, the first mall should be chosen in order to maximize profit. Choice 2, the second mall should be chosen in order to maximize profit. Choice 3, either of these two malls may be chosen, the profit is the same. Okay, so 1, 2, or 3? Hopefully it's a little obvious at this point. Okay, so 2, fantastic. Okay, now notice though why it might be important to work this out. If you look at the original information, you were told that, you know, if you're successful at the first mall, you could get $75,000 in annual profit. And so that could be really enticing, okay, because that's more than the $50,000 that you're expected a year at the other one. But what's going to happen is 1 year you're going to be successful. The next year you're not. Okay, you know how the economy is. Okay, you guys know how the economy fluctuates, okay? A few years back, the housing market was great, okay? Then not so much, and so on. So that's why it's important to look at what's expected over the long run and not necessarily look at what's happening right now, because that's what these numbers are, is what's happening right now. So, so again, you could be really enticing, but when you look at the numbers, oh, okay, so it looks like I'm going to do better at that second mall if I go that way. So this is you know, an occupation that somebody does. You know, they help businesses figure out what would be the best expected value and so on, so that you can make better decisions for your company. Is it always going to end up this way? No, because that's the nature of probability. You're still taking a risk, because even though the probability may be high, something else can happen. So, all right, so for homework so far, 11-8.